Welcome back. This is Physics Unit 1, video number 5, and you are looking at a handout. If you are present at school, you will have received a paper copy of this. If you are doing this all from home, there is a copy of this as a PDF available on Prism. So we are looking at this graph. It is a distance time graph, and we are going to analyze the different types of motion that are present here. So the first thing that we're going to look at is from the period of A to B, here to here. And if you are coming to school as an in-classroom student, you'll probably see a demonstration of this motion in the hallway. We'll try to reenact it. If you're not here, then maybe we'll try to figure out some way. First off, let's describe what's going on with point A to point B. So zero distance is the home position, so we are moving away from home. And if you look, this looks like a pretty straight line to me. Straight line tells us in uniform motion. So from point A to point B, we are moving away from home in uniform motion. So let's figure out our average speed. Remember, we start with our formula and symbols, then we can put in our numbers. So the distance, how far have we traveled? Well, the distance is from 0 to 4 meters. That means the change in distance is 4 meters. The change in time, we did it over the course of 1, 2 seconds. So without using your calculator, we find that the average speed is 2 meters per second. On another note, we can talk about instantaneous speed. Instantaneous speed is how fast we are moving at any given point in time. So at this point in time, I'm going a certain speed. At this point in time, I'm going a certain speed. At this point in time, I'm going a certain speed. The instantaneous speed, if you remember from our tangent discussion, would be tangent to the line. So if the point X, the slope is the tangent line, and that is instantaneous speed. But we don't even need to make a tangent line because what is the instantaneous speed at time of 1.5 seconds? So a time of 1.5 seconds would be here. What is the instantaneous speed here? Well, this is a straight line, and every point on the straight line has the same slope. So even if you tried to draw a tangent line, it would still be the same slope. And so the instantaneous speed at this point is the same as the average speed for the section, and it is 2 meters per second. From B to C, what's going on with this graph? So we are looking at from this point to this point. You know what? Let's make these different colors, make them look a little different. Okay. All right, from B to C. So from right here to right here, what is going on here? If you look at the slope, we have a pretty big slope. Slope is smaller, slope is smaller. The slope continues to decrease. And if you look back at page 7, this looks a lot like graph F. So what I'm going to say for section BC is that we are slowing down. Use green for the next one. From points C to point D, what is going on with this section? It's a straight line, which means it's moving at a constant speed, but it's horizontal. And a horizontal line tells us something specific. Refer back to graph D on page 7. It was a horizontal line with a slope of 0. What this tells us is that we are stopped. And we even know how long we've stopped for. We are stopped from here to here, which is 1 second. We've stopped for 1 second. I'm going to go back to blue for the next one. We are looking at section D, E. Scroll up and down here. For section DE, what's going on here? A couple of things that we could notice. It is a straight line, which tells us constant speed or uniform motion. But if you look at the distance starts at 5 and ends at 4. And we had some terminology for this. Refer back to graph C on page 7. And let's describe what's going on here. We are moving toward home in uniform motion. We know it's uniform motion because it's a straight line. We can figure out the average velocity based on the change in distance and the change in time. If we look at the change in distance, that would be 5 that would be y2 minus y1. So we have 4 minus 5. Maybe I should write this out. 4 minus 5. And we'll say that's meters. Probably not the right way to say that. Hold on. There we go. And the change in time. So at the second point, that's a time of 7 seconds, minus this other time, and that is at 4 seconds. And so what we have is negative 1 meter over 3 seconds. Fractions aren't really the greatest thing in physics, so we are going to put this in more the decimal form. This would be negative 0.333. Repeating, but I'm going to stop there. And that's meters per second. Some things we can take from this: a negative velocity, something we'll look into soon. This is a vector and it has a direction. The negative tells us that we're going towards home, so it implies a direction. What it means is going backwards. For sections E to F, I'm going to erase some of this. Less scrolling. Okay. Section E to F. And malfunction. From E to F, what is happening? We are heading towards home. Here it is. And then we kept going. And it looks like a straight line to me. Uniform motion. Straight line means uniform motion. So let's write in what we think is going on here. We are going toward home. And passing home. We went a little too far. Straight line tells us in uniform motion. We can calculate the average speed over this interval, change in distance over change in time. So here's -1 meter minus 4 meters. And time is 10 seconds minus 7 seconds. So we have -5 meters over 3 seconds. If we were in math class, -5/3 would be a great answer. But in physics class, we need this in terms of decimals, -1.67 rounded meters per second. Section F to G. Here we have a straight line. It is horizontal. As we know, horizontal means we are stopped. And we have stopped for 2 seconds. We've stopped for a period of 2 seconds. We'll just put the reminder here: slope equals speed, and here that is 0. Last one, looking at section from G to H. From G to H, what's going on here? There's a straight line, uniform motion, constant speed. We are going from -1 meter away from home to 0 meters. We are going toward home. The closer you get to 0, the closer you are to the home position. So let's write what's going on. Toward home in uniform motion. Parentheses, I'm going to put we are moving forward. Finding the average velocity, that's distance over time. Distance, we moved a total of 1 meter. Time, it is 1 second. And so we are moving at a speed of 1 meter per second toward home. And after all of this, we can say that he ended up at home. After this long trip, he's gone away from home, he's taken a break, he's turned around, he's taken another break, and he ends back at home.